Hi everyone, my name is Ayush Goel, and today I'll be talking about my research web archival in the era of JavaScript. This is joint work with my colleagues at University of Michigan and Princeton University. Today I'll be talking about two major problems caused by JavaScript on modern web archival. First, it significantly inflates the web archiving cost. This is because the amount of JavaScript bytes on modern web pages has been continuously growing up. For example, in the last decade alone, there has been a 400% increase in JavaScript bytes. The second problem caused by JavaScript is the fact that archive web pages render poorly. That is, they are visually broken because of a lot of 404 errors. The key reason behind this is that there is a variation in JavaScript execution across multiple loads of the same page. For example, here are screenshots of two different pages loaded from Internet Archive. In both these pages, a bunch of page resources are missing. These resource URLs are generated via JavaScript execution, and the result of this execution varied between when the page was crawled and when this page was loaded from Internet Archive. Having established these two problems caused by JavaScript, let's look at our key insights to overcome them. First, in order to reduce the storage overhead, we observe that a large amount of JavaScript can be safely discarded as it serves no purpose on an archive page and is essentially irrelevant. The second insight is that in order to improve fidelity, the rendering of the archived version of the page should mimic that of the crawled page. Now let's look at each of these issues separately. In order to improve the page fidelity, we have to ensure that the URLs that are generated as a result of JavaScript execution do not vary or diverge. And therefore, we have to handle the source of such JavaScript variations. One source of such variation are inbuilt browser APIs such as date, random number generation, performance APIs. In order to handle any differences in URLs due to these APIs, we simply use server-side matching techniques. For example, let's look at a URL where there is a timestamp at the end of it, and one such URL was stored at the web archive. Now, when the user loads this page, a different URL can be generated because a different timestamp would be returned. In order to ensure that a corresponding URL is located for the incoming URL, you can use server-side matching heuristics to account for such minor differences. The second source of JavaScript variation are client characteristics. For example, different browser types, such as Chrome, Firefox, or different client device itself, for example, a desktop and an iPhone. In order to ensure that all the variations in URLs caused due to client characteristics are handled, we enforce the same client during crawling and loading of pages. Now, having solved the issue of poor fidelity, let's look at how to reduce the storage overhead of JavaScript. We look at two orthogonal techniques. One, eliminating non-functional code, and second, eliminating unused code. Let's look at each one of them separately. Non-functional code is any code that interacts with the backend origin server and therefore would not work. For example, in the case of Forbes.com, push notifications would not work when loaded from a web archive. And therefore, the JavaScript library enable the push notification functionality can be safely eliminated without any loss in fidelity. Now, the second technique we use is eliminating any code that will not be used. In order to do this, first, we need to actually identify the code that will be used. For example, on modern web pages, a lot of JavaScript code enables user interactions. On this page on homedepot.com, you can click on the menu button, which expands the menu drawer. Also, JavaScript code needs to be preserved. However, any code in alternate control flows can be safely eliminated. For example, on the same page, the geolocation API is used to determine where the user is surfing this page from. The same code also contains a lot of error handling code in case the geolocation API fails. Since this would never be the case in case of a web archive, all the geolocation error handling code can be safely eliminated. Finally, I would like to summarize my presentation with the key results from our work. First, there was a 41% reduction in the storage needed for a corpus of 1 million pages. This includes all the resources for those pages, HTML, CSS, images, and JavaScript. Second, we were able to eliminate almost all failed requests for page resources. That is significant improvement in fidelity. And as a side effect, we were also able to improve the rate of crawling by 39%. Thank you, and I'm happy to answer any questions.